Good. So good afternoon, everyone. So let's get started. Last class, where were we? So let's see. This is the code that we have seen from the last class. This code you are all comfortable with, right? So we are trying to compute the sum of first n natural numbers. And let me use my pen. So here we are reading the input. Here we are reading the input. And here we are, this is output. This is input. This is output. What's the problem? We have to compute sigma I is equal to 1 to n I. And then we have, this is the core compute logic. So from here, this is from here to here. This is the logic. So what are we doing here? We are starting with our initial estimate of sum is equal to 0. Uh, this is our initial estimate, and this estimate keeps improving as the value of I keeps changing here. So sum is equal to this, but initially we put 1 into sum and then we add 2 into sum and then add v. So this is like initially we have sum is equal to 1, and then after that we want to make, in the next iteration, we want to add 2 to sum, and then we want to have sum is equal to 1 plus 2 plus 3. So in every iteration we want to add I to the variable sum. So this is what we are doing. So we say I is equal to 1, we start, and then we check if I is greater than n. If I is greater than n, you go to the control transfers to the statement which is labeled end. This is on line number 22. Otherwise, line 16 and line 17 gets executed. On line 16, accumulation of I into sum happens, and on line 17, we increment the variable I, and then on line 19, you go back to the beginning of the loop. And on line 19, you go back to the beginning of the loop. This is what we are doing. Are you all good with this code? This just quickly reviewing. You're all good with this code, right? Why we wrote go to end? So if we don't have go to end, how do we exit the loop? We are keep going. At some point, if I is greater than n, we no longer want to add continue. So we should go to end. So that's the reason why we have go to end here. So when we hit this go to end statement, what happens? The control will go to the statement. Let me use a different color. The control will go to this statement, which is labeled here. If I is greater than n, then nothing, no? So you just go to n. If I is equal to 1 or anything less than n, then line 16 and 17 will be. Can you exit the loop using else command? No, don't worry about different options. Just there are many ways to write the code. We will see, Kartikeya, your approach, but I'm not sure about your approach though. But for the time being, I want all of you to be on the same page on this code, how this code works. Are you with me on this code, Kartikeya? This how this code works, the code that we are seeing on the screen. Okay, good. So now let's get going. So otherwise, I think maybe okay, good. Great. So now let's try to write the code for the MAGS program. So what is the max program? You will see a series of numbers. You read from the keyboard 12, 30, -1, 40, 18, no, maybe -2. And the max of all these things is 40. The max of all these things is 40. And that's what we should print on the screen. So here, hash include stdio.h. So here, this is a program in which we kind of intersperse input reading and computation. So we intersperse in reading of the input and computation. Let's see. Yeah, max. In this program, we read the input, we did the computation, and we printed the input. But in max.c, so as we keep reading, we also do some kind of computation. So that's the tricky part here, right? So what do we do? So let's say in a variable called int current underscore number. So there's a variable current underscore number in which we read the current number. Like initially, if it could be true, so we do this scanf %d and %. So there are two things about scanf. So let's say this is the program. We didn't yet write anything yet. So what will scanf return? So what does scanf does? What does scanf does? Can you tell me all the things which scanf does? You studied in the previous class, right? So what all the things scanf does? No answers? It reads the input and stores. What else it does? Is it the only thing it does, or returns? Yeah, returns the number of successful inputs it has read. It returns the number of successful inputs it has read. So if you look at int ret value, so let's say I will store ret val is equal to this, and then I will say printf %d ret val, and yeah, number is equal to %d. Right? So I want you to understand this. Scanf is a kind of, it's what is called as a function. So there are two things it does. It changes the, whatever the input, it reads from the keyboard, it assigns it to the current underscore number variable. And it also returns the number of values it successfully read. So now let's say GCC. So what is this max.c? Let me GCC max.c. Great. So dot/a.out. So if I enter 20 and enter 10 and enter, now if I press an enter key, what will be the output that will be printed on the screen? What will be the output printed on the screen? Yeah, 1, 20. So one value is successfully read, and the contents of that variable also we are printing. So the contents of the variable is 20. So if I press 23, so if I press enter, what happens? If I press enter, nothing happens. It is printing 1 because it scanf successfully read one integer from the keyboard buffer, and that is the value it returns. That is the value it returns. All right. So now, let's say if I press the character A, okay, some random character X, what will it return? Now, it will not be able to. Scanf tries to read an integer from the keyboard, and and it doesn't get an integer. So what happens is, no, it would not still proceed. It's not true. It proceeds actually. So when I press X, you can see we come out of scanf. We come out of scanf tries to read an integer from the keyboard buffer, but it hits an X. And since it hits an X, which cannot be converted into an integer, so we come out of scanf and return value will be 0, because it and current underscore number, it's not assigned any value. It contains some garbage value. So scanf, when we print here, the ret value is 0 because scanf is not able to read anything from the keyboard buffer, and current underscore number is not assigned any value. And so because of that, when we print current underscore number, the value that is printed on the screen, it's a garbage value. No, spaces will be ignored, right? So no, Anirudh, when we have these spaces, spaces will be ignored. No, that is the semantics of the scanf. Scanf says when there is a space, you space, white space characters, enter, they will all be ignored. That is how scanf is defined. So are you all with me here right now? On this thing you are here. Why scanf? What scanf is doing? Scanf returns the number of. So let me summarize here. So for case one is simple. You enter a valid integer. Okay, you press enter. So you enter 12. In this case, the return value from scanf will be equal to 1, and current underscore number will hold 12. Case 2 is no some random character, like let's say X, and then you press enter. So scanf will not be able to map this X into, translate this or convert this X into an integer. So the return value becomes the ret value is equal to 0 because it's unsuccessful in reading anything. And when we come and print here current underscore number, it contains some garbage value. So these are the two cases we should remember. And this is important to write this program because, so here what we do, so now I am removing the statement on line 12. It serves the purpose. Yes, Adarva, tell me. So we check if scanf is successful. If scanf is successful using an if statement. Yeah, we would get an ASCII value. If you use %c and if you press a character, then you get the ASCII value of the character. That's true. So we do, if scanf, if it is not equal to 1, that is, you enter a sequence of numbers, right? You enter a sequence of numbers, 10, 20, -1, 40, and then you press some character, some A, X, whatever it is, then all these numbers will be successfully, we would like to read them. But if any character is, any other character is pressed, we want to come, it kind of says that it is a, no, that sequence has ended. So if the sequence has ended, what should we do? If the sequence has ended, what should we do? What should we do if the sequence has ended? Yeah, before we yeah, we should kind of go to end, but approximately this is our so what we are trying to do, let me make this one clear. Let's make the logic of the program clear. The logic of the program is this. So there is this thing. So we have this current number. Cn stands for current number, okay, as a shortcut. And then we have mags. We have mags. This mags is a current estimate of mags. So initially, when we start the program, so let's say in state 0, when we start, our current estimate of mags is undetermined, because we didn't see anything, so we don't know what is the current estimate of mags, right? And then, so you read one number, let's say that number is equal to 12. So you want to compare 12 with the current estimate of max. This is the current estimate of max. So what we do is, so there are two things that happen. So there is this value coming from here, and there is this value coming from here, and you compare 12 with this, and you want to say that 12 is the current estimate of max. And then after that, you read, no, let's say 40. So when you read 40, so the new number, you compare it with the current estimate of max, and the current estimate of max will be 40 now. Let's say after that you read no, -1, and what you do is you compare -1 with the current estimate of max, and the current estimate of max will still remain the same. It's not going to change. And then after that, let's say you read one more number, let's say 100, and then again what you do is you compare 100 with the current estimate, and 100 compared with 40 is, let me use, is 100. So we improve the estimate. So are you all with me on this? And then finally, let's say you press something like some character, some termination character you press, and then you know that the sequence has ended. So what you do is you print this as the mags of the sequence. This is our algorithmic idea. Are you all with me on this idea? Does it make sense? This is our goal. This is what we would like to do. So there are a couple of challenges. The challenges here is in the initially we don't have any max value. There are a couple of ways of taking care of this. One way of taking care of this is if we know that we are dealing with numbers between no, L to U, like for example, if you are trying to find, it's the numbers that you are reading is the marks in the exam, and you know that the marks in the exam range from 0 to 100. So then you can take the current estimate of max, the initial estimate of max, as let's say -1, for example. Do you understand here what is happening here? When we start this whole story, and if we know that the numbers, no, it's marks and there are no negative marks, so we can start the initial estimate as -1, for example. Zeroth state, this zero means it's like zeroth state, zeroth iteration, first iteration, second iteration, third iteration, fourth iteration, so on and so forth. Are you all happy? So there are two approaches. There are two bootstrapping approaches. So two bootstrapping approaches. We will first use the simple bootstrapping approach. Two bootstrapping approaches. The first simple bootstrapping approach is the initial estimate of max. We can, let's say we know, as I said, we are dealing with positive numbers because we are working with bootstrapping means when you are when your program is getting started, like for example, we want to keep improving our estimate of max. But what would be the initial estimate of max when we don't see anything in the anything at all? If you don't see anything at all, so one is first value. Before we look at the first value, what should we do? So here, what should we do? What should be the, so here, what should be the max value? So there are a couple of ways of looking at it. So one way is, let's say, for example, if you are dealing with marks and we know that that marks cannot be negative, in which case what we do is we say we say initial value of max is equal to -1. Initial value of max is, see, we want to start, before we see any sequence, what is our whole approach for this program? The whole approach for the program is we want to keep improving our estimate of max. But what is the initial estimate of, and the way we are going to improve the max estimate is by comparing the new number that we see with the previous estimate of max. So this kind of works subsequently, but initially in iteration 1, once when you read 12, let's say as the input, we want to check whether we want to check 12 again as the current max. So what is the current max value? We don't have it. So in order to have it, if you know something about the domain, let's say if you are trying to find the maximum marks, then we know marks cannot be negative. So we start our initial estimate of marks as -1. That's all I'm saying. We will take care of that. So what if the input has negative values? We will in that case we will take a different approach. Good question. So now if scanf is not successful on line 8, if scanf is not yeah, that initial, not the initial estimate is the bootstrapping. Okay. So what do we do? So we if scanf yeah, so this is what we do. So go to L1, so go to end. So when we see a number, when in the sequence, if you see an input which is not other than a number, then we would like to terminate the program. We would like to come out of the program. So because of that, so when scanf sees something other than a number, it returns a 0 value. So we are just checking it's not equal to 1. That's what we are trying to do on line 8. And then we go to end. At the end, what we do, so we just want to say printf. So now, hopefully, by the time we come to the end, we want to print maximum %d /n max. So here, so we know, like at the end we want to print the max, and we are reading the input one line after another. And then on line 11, what are we trying to do? So here we check if max is no, if current number is greater than max. What should we do if current number is greater than max? What should we do? What should we do on the max is equal to current number? That's it. And then after that, what should we do here on line number 15? What should we do? Line number 15. You should go back. Go to 8 exactly. Go to line number 8. So how do we do go to line number 8? We'll say go to loop or go to begin, whatever it is, and say begin is equal to this. That's it. Are you with me here on this program? Does this program make sense? Anyone have issues with this program? We keep iterating. So here we keep iterating. So we come here, we go back to the beginning. No, we go back to the beginning. And at some point when you see a number which is from the input keyboard, if you see anything other than a number, what happens is this scanf returns a value 0 or -1 depending upon how it goes. And so we'll come back here and we print maximum. Are you all happy here? Do you see what's going on? Anjali, how about you? You asked it about this question, so I hope you are. Okay. So now let's run this program. VCC max.c. And then let's say press 6. Come out of the program. That's it. So there is one more thing I would like to say here. It is possible for you to give input in a file. So dot/a.out less than input.text. Did you see? Do you understand? So it is possible for us to give the input in a file and then you can redirect the input by using this command. This is what is called as an input redirection. So what the shell will do is your program. So I'm giving this whole, this is the whole command. This is the whole command. This is the whole command. So this, I'm using a bash shell. What the bash shell will do is the contents, this is your keyboard buffer. This is your keyboard buffer. This is your keyboard buffer. Approximately speaking, what happens is whatever that is there in the input file, it will be kept in this keyboard buffer. And the a.out will consume the input from the keyboard buffer. So when you are testing programs, this is a nice way to test programs because you don't need to keep on entering input on the keyboard. You just put the input in a file and then you just give this command, it works. So it's easy for you to debug your code. Don't worry about the keyboard buffer part. All I want you to understand is, whatever that the contents of the input file will be provided as input to the a.out file. Are you with me here? The contents of the input.txt file will be provided as input to the a.out file. If it is not there, then you will get into trouble. Let's see. You just try it out and see what happens. Let's say it's not there. So bash itself will say, input1.txt is not present. So bash gives an error message for you. Your program is not even executed. Are you all with me here? Are you all with me? Bash is the shell. This is this. There is a shell, and if you are using, if you are working on Linux or in any Unix environment, you will get a shell. There are multiple shells like Bash shell, C shell, things like that. Okay. On terminal, No, there are different terminals. Good question. So bash shell runs on a terminal. Yeah. I. What do you mean by exit with alphanumeric? Agree. Uh, let's not worry about it, Grim. So I know what you are getting. Uh, so so what happens is 40 will be read as an integer and x will be terminated. So you got it, Agree? What happens when we give 40x? The till 40 it will be read as an integer, and x will force will no. When scanf looks at x, uh, then it says it cannot process the keyboard buffer anymore. X40 also doesn't work. Yeah, four scanfs here. Three scanfs happen. Here four scanfs happened, but the fourth scanf is a failure in the sense it repeated 0 because it's not able to map x to uh, an integer. You want to see the code? Let's go see the code. Let's not worry about the shell and all those things for the time being. We'll get into a different direction. Good questions though, but you will learn a bit later. And here, since like the body of the if statement, since there is only one assignment statement, we can just write something like this. We don't need the left and right flower bracket. Okay, are you fine with this? Did we study ternary operators in the last class? We studied ternary operator, right? Yes or no? So what can we do to make this code much more smaller? How can we rewrite the statement 13? So max is equal to what? Current number is greater than max. Then current number is the max. Does this make sense? Line number 60, since we discussed a ternary operator from the last class. Okay. So see how the whole code is now compact. The whole code, it's pretty much very, very small code. And what is the good thing about this program? So this program is you don't need to tell how many inputs, how many numbers are there in the sequence. You keep reading. At some point, you can uh, terminate the sequence by pressing a character other than a number. Now I want you to understand one more thing. So I want you to understand one more thing, that is, so there is an alternate way of doing what we are doing on line number 9. So that is, so max end of file. There is what is called as an end of file symbol. We can say if scanf if it is not, if it is equal to end of file. So there is what is called as an end of file symbol. And so end of file symbol comes, let's say, let's compile this code and see what happens. Okay. So GCC control U, GCC max end of file dot C. So here you keep pressing different inputs, and in order to say that you have reached that the input is completed, you can press Control D, and when you press Control D, CTRL, I'll just write here Control D, and no, that 34 gets printed. That means the input buffer is we reached the end in the input buffer. So you can use, this is the second approach that you can use. And this approach also works, like for example, so now it's a good question. If you press X, will it work? So that is the question that I would like you to, it works for when we write code like this. So this is the challenge question I gave to the other class. So this is the challenge question. So there are two ways of handling this. So this is the challenge problem. So one way is equal to end of file, and case 2 is the way we did it before. It is not equal to 1. These are the two things that we used here to check if the sequence has ended. I want you to explore. So in this in case 1, if we press X, what happens? X or any other character, what happens? In case 1, if we press X, what happens? These are the questions I want you to explore. This is a homework for you. So case 1, if input X, what happens? Input X, what happens? Okay, input X or any character in case 1. And in case 2, yeah, case 2 should be all right. It will kind of work for any case. So this is the question. The challenge problem for you is when you enter some random character, so what happens and explain the behavior. So why that behavior? Explain the behavior of the program. Are you with me on this challenge problem? This is a very nice problem to think. So challenge problem. Okay. So Nitin, I heard it looks like we discussed that thing in the last class. So what does line 16 do? You tell me. Did we do this in the last class? Just I forgot, so I'm just. Anyway, since I'll quickly explain. So Gokul Raj, it's a good question. I want you to explore that question to your answer. Okay, so good question. So these are all nuances of C. In the long run, they don't really, they are not such a big deal, but you need to know them. Yeah, that's what I would say. So here, so this is a condition. This is a condition. If this condition is true, so this is what then current underscore this value will be assigned to max. This whole thing, it returns a value. What is the value returned by this whole expression? This whole thing, it's an expression. It's an expression. So this is, let's say, this is, remember in the last class we were writing expression trees. For the sake of simplicity, I will use Cn as a shorthand for current underscore number. So what we are doing is, so Cn is greater than max. So this is what we are, this is the condition. And so there are two things for possibilities for this condition, uh, true or false. Okay, let me use the words true or false. So if it is true, then no, this is the one, Cn will be written, or maybe let me use the other way around, so that it matches. This is true, this is false. Cn will be written, otherwise max will be written. Does it make sense, Nitin? End of file is nothing, it's just a symbol. We don't, when you press Control D, so uh, and that means if the keyboard buffer is empty and if you press Control D and when scanf tries to read, if the keyboard buffer is empty, or so let's say, just want to see, let's say this is the keyboard buffer. Let's say the keyboard buffer is empty, or it is having, there are two cases. This is all, uh, so let's look at two cases. Clear all my, so case one, this is your keyboard buffer. In the keyboard buffer, when it is empty, it is KB is empty. This is keyboard buffer empty, KB, keyboard buffer empty. And then you press Control D, CT. And when you press Control D and when the keyboard buffer is empty, scanf returns end of file symbol as the EOF symbol as the return value. Are you with me here? When the keyboard buffer is empty, you pressed Control D, then scanf returns a EOF symbol. Josh, are you with me here? Josh, Ujjwal. No, don't worry about you. Don't, Anirudh, don't digress, because when we use hash define, that's not how it works. Because scanf returns EOF, so it's, just understand this, okay? Let's try to understand the basics. After that, we will. The second case is this. The second case is there is a space here. This is space. This is space. And then at this point, you press Control D. Then again, so when you call scanf keeps scouting for an integer, and then it hits there, and then it hits a Control D character, in which case again it will return end of file. Space or tab, or this can be any of the white space characters. It can be space, tab, end of line. So that is /n. You can if these characters can be any of these characters. Scanf keeps ignoring them. It tries to scout for a integer. It doesn't hit any integer, but instead it got a Control D. So in which case again scanf returns a end of file symbol. Are you all with me here? End of file symbol is defined as -1. No, it doesn't return end of file. So there are conditions under which scanf returns end of file. I don't know all those conditions. So you should just read a man page of scanf. Man scanf, go to search for end of file. You can see, and what are the conditions under which scanf returns end of file. EOF is also returned if a read error occurs, in which case, yeah. So there are conditions under which end of file symbol is written. Yeah. So I'm not. Let's not get into all those details right now. So I want you to take a step back and understand these things, couple of things. Number one is there is a core algorithmic thinking or logic, program logic part. Like for example, in the case of max, the core logic part is very simple. What is the core logic part? You start with an initial estimate and you keep improving the estimate. That's all. Are you all with me on that logic? Are you all with me? Yes or no? Have an initial estimate, and as you keep seeing the numbers, you keep improving the estimate. That's all. See, it's just two-line logic. But once when we go to C programming language, the language has its nuances. Like for example, like you have some idea in your mind, you want to express it in English or in Telugu or in Hindi or in Sanskrit, and every language has its nuances. And all these things about scanf equal to end of file symbols, all these are language nuances. And these language nuances, like you can easily, with some input from me, you should be able to pick them up from the textbook. Okay, I want you to get the core computational thinking part. You should get from here. There are some nuances, and those nuances, by reading the textbook or looking at for some resources, you should be able to get. So now I said there are two bootstrapping approaches. One approach is this, right, where we start with max is equal to -1. But what if the numbers contain no negative numbers also? Then it's an issue, right? So how do we solve this problem? So in order to, the way to solve this problem is, so we say we use a, so we kind of leave max as it is, and then we say, so unit underscore flag. We say that the system, there is a flag variable we use. This flag states when the flag is equal to 1, it states that, you know what, the system is in a is in the bootstrapping mode. So when the system is in the bootstrapping mode, what do we do? So we check if init underscore flag is equal to 1. If it is equal to 1, the system is in a bootstrapping mode. If the system is in the bootstrapping mode, then what we do is whatever the current number that we have read, it will be the max. On the other hand, and then, so now the system is bootstrapped. So now we make this flag is equal to 0. We say that the system has already bootstrapped, so we don't need to, uh, you know, format. In order to make this clear, I'll write it here. Are you with me here? Can you see the approach that we took here? We used a flag variable to say that the system is in the bootstrap mode. And in subsequent iterations, we are out of the bootstrap mode, and we just use line number 19 to figure out whether the current number is greater than the max or not. Are you all with me on this code? Yeah, we can use any variable instead of init underscore. Confused? Tell me otherwise. So initially, this is what, in the, so when we are starting, when we read the first number, we don't have an estimate of the max. When we read the first number, so when we read the first number, what will be the value of max? We don't have any value of max. So when we read the number 10, let's say this is a sequence 10, 20, minus 140. When we read 10, that's the first time when we read 10 using the scanf statement here, we don't have an estimate of max. There are other approaches. Case, can you just try to follow the logic that is being used here? So sure, there are other approaches are possible. So but let's try to follow the logic that is here. So here, so we when we read the number for the first number, so what happens? We read 10, and yeah, so we read 10, and so we don't know the max. So because of that, how do we know that we are in that the 10 is the first number that we read? Because the init underscore flag is equal to 1. Forget about that bootstrap word. That what I'm saying is, when you enter the program for the first time, when you read this number for the first time, our idea is to compare this number with the current estimate of max. When we read 10, what is the current estimate of max? We don't have any estimate of max. And how do we know? So on line number 13, so we know that this flag is equal to 1. That means just we started the program and we read the first number and we don't have current estimate of max. So what we do is we just make the current number equal to max, and then we make init underscore flag is equal to 0. You try to write that program, Prashant. There are different ways of writing the program, so you can try to write the program. That's true. You can do that. Okay, there are different ways of writing. This is one approach which works in many cases. That's the reason we are taking this approach. Why are you coming back to EOF again? EOF is not a variable. It is what is called as a macro. Its value will be equal to -1. Don't worry about bootstrap. Don't, I just use it some word, forget about it. Bootstrap means when we are starting the program, when we are starting the program for the first time, when this program is iterating, no, this program is going in iterations. When we enter it for the first time, okay, when we enter this part, and this is the part where we are going in loop. So what is bootstrapping? So when we are entering this for the first time, we have to set up some stuff. And that's what I meant by bootstrapping for the first time. But later on, when we come back here again, that's not an issue. Okay, that's not an issue. How many of you are with me on this program? Does it make sense? You got enough time to stare at this? Anyone having problem still? Okay, great. So now let's compile this program. See, Anjali, this whole program is to read multiple inputs only, right? So that's the purpose of this whole program we have seen. Na? Are you seeing that we are able to, this is all about multiple inputs? We will see. And maximum is 23. So now with negative numbers also it will work. Are you good here? Shall we, you want me to stop here or you want me to take up the next set of ideas? Maybe we can take 15 more minutes and yeah. So, so now this, what's the problem with this code? Is there any problem with this code? Is there any problem with this code? Unnecessary variable. Okay. What else? What if the input sequence is empty? I pressed Control D. So when the input sequence is empty, what is happening? I'm getting a garbage value for maximum. So if the input sequence is empty, what happens is you enter the here, and then on line 11, so you go to end and you print some max value. How can we solve this problem? How can we solve this problem? If the input sequence is, yeah. So what we can do is we can check if init flag, if it is equal to 1, then we will say sequence empty. See, now it says the sequence is empty. You cannot raise exceptions in C programs, in C programming. Great. So let's do one thing. I will pause the lecture here, and what I will do is, uh, I'll push this code, and for the other section, so today I'm able to take from here and be able to cover loops and many other ideas. So maybe you can watch that lecture, and then on the Tuesday class, we will kind of discuss any doubts you have in that. And uh, yeah, so what do you think? Is it a good idea? So essentially, the next set of ideas is I want to introduce how to use for loop, how to use while loop, and so that video I will post. You can give it a try, watch it, and then see how much you are able to understand. And in the Tuesday class, we will take up the discussion on it. That's a good approach we can take. So. And so if there are any issues, it's not like I will not cover. Watch the video lecture carefully, and on not this is not on section A. This is only for section the previous section lecture. The section no, I took this code base B1. Yeah, B1 section code base. I used the same code base I used, and then we looked at for loop, how to write while loop, how to write for loop, etc. You watch that video lecture before you come to the Tuesday class, and then we will pick up the thread in the Tuesday class from there. Yeah, I will upload this code in the I will upload this code on the course website. Or so Harshil, we will pick up that your doubt, maybe no. I will take a look at it and then I will get back to you. Just drop me an email, right? Already.